Section 12.1, Day 2, we're going to look at using right triangle trig to solve for angles. We'll start with the warm-up. In the previous lesson, we looked at how you can use right triangle trig to solve for missing sides. So here's an example. Draw a triangle that meets this formula and solve for r. So we know it's a right triangle, and so we'll start by drawing one of those. Right triangle. Okay, so here's my right triangle. Let's put in our 90-degree angle. Cosine of 27, so I'm going to put 27 at one of these angles. And cosine is adjacent over hypotenuse from SOHCAHTOA. Excuse me, the hypotenuse is the longest side across from the 90, so there's where that goes. So the adjacent side is the other side next to our angle, so this will be r. So there's a picture for the equation, and we can cross multiply and solve. So we have r equals 8.5 cosine of 27, and you can just type that in your calculator to get the length of r, and it's about 7.57. Review, label the sides O for opposite, A for adjacent, H for hypotenuse if the angle is x. So this is our reference angle here. All right, hypotenuse, longest side across from the 90. Adjacent is the other side next to your angle. That's not the hypotenuse. And here's the opposite side right here. So be careful. Usually we've been putting our angles down here, but if your angle is somewhere different, you have to change your sides accordingly. Again, a review of the trig ratios from yesterday, SOHCAHTOA. So here's the shortcut SOHCAHTOA. Sine is opposite or hypotenuse. Oops. Excuse me, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA, yesterday we wrote it like this. Sine of theta, your angle, is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. To find the angle measures, use the trig. To find angle measures using the trig functions, we're going to use something called the inverse. An inverse is an operation that undoes something. So we know when we're solving something algebraically, if you have a plus, the inverse is a minus. If you have a multiply, the inverse is divide. If you have something squared, to get rid of it, you square root. So to get rid of a sine, cosine, or tangent, we're going to take the sine inverse, cosine inverse, tangent inverse. So we'll do an example. Let's solve for this angle here. Notice you could use Pythagorean theorem to solve for the missing side, but they don't want a side here. They want the angle. So again, let's look at our angle and see how the sides are related to this angle. We have the hypotenuse. We have the adjacent side. So that tells me to use cosine. So cosine of theta equals adjacent over hypotenuse. Our goal here is to get theta by itself, the angle by itself, so to get rid of the cosine. Again, you do the cosine inverse. So here's what it looks like. Theta equals cosine inverse. That gets rid of the cosine on this side, so then you do it on this side as well, of 6 over 10. So again, cosine inverse gets rid of this cosine, and what you do on one side, you do on the other side. We don't show it on this side because we've gotten rid of it. And then you type that in your calculator. So on the inspires, use that trig button here, all the inverse functions. So there's cosine inverse of 6 over 10. And that angle is 53.13 degrees. So I'll just round to the nearest degree. It's about 53 degrees. Ooh. So to solve for a side, remember you can cross multiply. But when you're solving for an angle, you're going to take the inverse of the function. To solve for a side, cross multiply. To solve for an angle, take the inverse. So today we'll do several examples of solving for an angle. And then on your assignment, you'll practice that. And practice probably both methods. Example 1, a 12-foot ladder is leaning against a house to a window that is 10 feet high. What angle does the ladder make with the ground? Let's draw this picture. So here's my right angle. The ladder is 12 feet. The window is 10 feet high. What angle does the ladder make with the ground? So I'll call that x or theta. Again, identify your sides. We have the opposite side, We have the hypotenuse. So if you look at SOHCAHTOA, that's sine. So sine of x equals opposite over hypotenuse. To get rid of the sine, take the sine inverse. So here's what that looks like, 10 over 12. Whoops. In your calculator, again, the trig button is where you'll find that inverse. Sine inverse of, what was it, 10 over 12. And it's about 56.4 degrees. So we'll write that x is about 56.4 degrees. Example 2, if the angle is cut in half, how far would the ladder reach up the house? Okay, let's give myself more room for this one. So again, we have our right triangle, and the angle's cut in half. How far would the ladder reach up the house? All right, so our angle was 56.4. We're going to divide that in half. It's about 28. If we divide that in half, I'll divide 56 in half. So this is 28 degrees. The ladder was 12 feet long, and it still is, so let's write that down, 12 feet. Ooh. 12 feet. Okay, so then how far up the house it reached, I'll call that x. Okay, so again we have the hypotenuse. We have the opposite side, so again it's sine. Sine of 28 equals opposite over hypotenuse, and this is solving for a side, so you cross multiply and solve. So we'll have x equals 12 sine of 28, and if you type that in your calculator, it's about 5.6 feet up the house. So before, it went up 10, but if you cut the angle in half, the distance up the house isn't cut in half, it's 5.6. Next example. Oops. Jordan and Willie are playing paintball. They start from the same spot, but Willie runs one way and Jordan runs the other. If Willie looks back at the starting line and then to Jordan, how many degrees did his eyes scan? So here's Willie, so he looks at the starting line and then back to Jordan. Here's our angle. We'll call it theta this time. Theta. All right, let's take a look at our sides right here. We have the opposite side. We have the adjacent side. We don't have the hypotenuse. So O and A is tangent. Tangent of theta equals opposite over adjacent. Theta equals the tangent inverse of 15 over 12. So if you type that in your calculator, you get about 51.3 degrees. One last example, and you'll practice solving for sides and angles on your own. A fire department's longest ladder is 110 feet long, and the safety regulation states they can use it for rescues up to 100 feet off the ground. What is the maximum safe angle of elevation for the rescue ladder? Okay, so let's turn this into our picture here. We'll make this into our triangle. Ooh. Okay, so here is our angle. I'll call it theta. And the ladder's 110 feet long, and it can go up the wall 100. So again, let's determine what sides we have here. We have the opposite side. We have the hypotenuse. So that is side. Sine of theta is opposite over hypotenuse. Take the inverse of that ratio. And when you do that, the safety angle can be 65.83 degrees at its steepest. Okay, so your assignment, you'll be practicing these two ideas, solving for sides, where you cross multiply, and solving for angles, where you take the inverse. One word of caution, make sure you're in degree mode.